Let's look at how to find the derivatives of the inverse trig functions. We're going to start with y equals the inverse sine of x. I'm going to encourage you to stop the video as we go through to see if you can figure out the next steps prior to showing them. First step here would be to rewrite this by taking the sine of both sides. So the equation is solved explicitly now for x. We have the sine of y equals x. Let's do implicit differentiation, and we end up with the cosine of y dy dx. On the right side, we have dx dx, which is 1. Ultimate goal is to get the dy dx by itself, so we'll divide both sides by cosine y. We have 1 over the cosine of y. We ultimately need our answer in terms of x, so we're going to try to figure out some way to connect the y's to the x's. We have a cosine of y. Above we have a sine y and also an x. So let's use the Pythagorean identity sine squared y plus the cosine squared y equals 1. We're going to solve that so that we isolate the cosine. So we'll subtract sine squared y from both sides and then take the square root. We get 1 minus the sine squared y under the radical. I can now substitute that back into the original derivative. We have dy dx equals 1 over the square root of 1 minus sine squared y. But we know that the sine of y equals x, so we can rewrite the right side as 1 divided by the square root of 1 minus x squared. That gives me the derivative of the inverse sine of x